Project code ITPW52. Project title: Power factor improvement in modified bridgeless Landsman converter fed EV battery charger. In general, the electrical vehicle in future the electrical vehicle is to charging in a EV station. In a EV station, the input is AC is given as a input and given to the diode bridge rectifier DBR and given to the boost or buck converter and to our vehicle battery. It is a basic electrical vehicle charging black diagram. But in this flow, we have a drawback in diode bridge rectifier and buck boost converter. If you're using the diode bridge rectifier and buck boost converter, diode bridge rectifier, the input side we get a low total harmonic distortion and the power factor problem in input AC side. In conventional method, the three black, one is diode bridge rectifier, second is boost converter, third one is flyback converter. In diode bridge rectifier convert AC to DC and boost converter converted DC voltage into boosted DC voltage and flyback converter is an isolated converter. It having one isolated coupled transformer. It will reduce the it is used for both AC and DC. So it can reduce DC high DC to low DC. By using the current controller is fed into the flyback converter. We have to capable of reducing the input voltage given to the battery for the battery capacity. In case battery is 48 volt battery we using, we have to reduce the boosted voltage from boost converter to the 48 volt by using the flyback converter. And flyback converter also having one advantage, having it reduced electromagnetic interference because it having coupled inductor. It can reduce the electromagnetic interference problem. While using the diode bridge rectifier, the input side total harmonic distortion having some problem. The main drawback of existing converter is in diode bridge rectifier using means the input current ripple is high, so total harmonic distortion problem is happens, and efficiency of the converter also reduced. In a proposed converter is named as a bridgeless. Why we said as bridgeless means the diode bridge rectifier is not used in this proposed converter, and the Landsman converter, this converter is parallelly connected with another Landsman converter, parallelly connect, and we get the boosted output. And Landsman each Landsman converter having one switches, one MOSFET or IGBT switch, and the pulse is generated by using the PI controller and given to the PWM and given to the MOSFET. So we get the boosted output. Again, the boosted output is given to the flyback converter. Already said flyback converter is capable of boost and buck operation is happened for even a AC or DC. So in case we have to use it for DC, so the DC it converted into the DC voltage. Depends upon the battery capacity. So without the diode rectifier, we already having the improved THD and power factor problem is also reduced. Size also reduced because the diode is not used in a proposed converter. So it is also used for the constant voltage and constant current mode for battery charging. Because the input is changing in AC side in electrical vehicle station, input is changing means the output also changing. So in case the output changing means battery having some problem. So the we have to maintain the constant voltage and current in the battery. So this proposed controller is used to capable of maintain the constant voltage and current. This is a proposed black diagram. AC supply given to the filter and again the modified Landsman converter. Why we said as a modified Landsman converter means we have to parallel to Landsman converter and flyback converter battery. The application is used for electric vehicle application and battery storage application. The software is implemented in a MATLAB 2015B, and in a hardware prototype, PIC controller is used to generate a pulse. So microprocessor lab is having to implement the program and given to the PIC microcontroller. And the hardware mainly used is a MOSFET and a transformer and PIC microcontroller, and other passive and active devices are used in a hardware. And finally, our proposed converter having diode bridge rectifier. We eliminate the diode bridge rectifier and give and bring the bridgeless Landsman converter. It eliminates the diode bridge rectifier, so we get good TH3 total hormone distortion under 5% and the nearly unity power factor, and maintain the constant voltage and constant current for the battery charging. Thank you.